Hello, this is Kason Kelly. In this lab, we are studying motion by using a motion sensor to track the movements of me and my lab partners while we recreate a few position time graphs that were given to us. The main focus is learning how to interpret position time graphs, which visually show how an object's position changes as time passes. By examining the slope and shape of the graph, we can tell whether something is standing still, moving forward, moving backward, or changing speed. This skill connects to many real-world examples. For instance, when driving a car, your distance traveled over time can be represented as a position time graph. If you were stopped at a red light, the line would appear flat, but as you accelerate and maintain a steady speed, the line would slope upward. Understanding these graphs help us translate everyday motion into clear mathematical terms. The purpose of this lab is to practice collecting motion data and then interpreting it through graphs. By doing so, we can strengthen our ability to connect real physical movements to graphical models and better understand how graphs serve as tools for describing motion in both the classroom and the real world.
Hello, my name is Conrad and I will be going over the materials. This is our first lab, so this will be the first time we use these materials. The motion sensor used in this lab is a Passport motion sensor. This sensor emits ultrasonic pulses that bounce off an object and back to the sensor. This data is processed through the online software Capstone and used to determine the object's position relative to the sensor at some point in time. We also need a computer to open the software. The computer is connected to the motion sensor through cables which allow us to determine the object's position, which can then be used to calculate the object's velocity and acceleration. For this procedure, we used the motion sensor to measure how close and far away we were from the table. The graph shows the displacement of the person from the origin, which is the motion sensor, and the person's displacement. Hello, my name is Conrad and I did the first graph. The data was inserted into the tables through the motion sensor that was connected to the computer. The y-axis represents the position of the object from the motion sensor, and the x-axis represents the time elapsed. In this graph, we see that the object first goes away at a fast pace to 1.5 meters, stays steady or stops at 1.5 meters for 2.5 seconds, and goes away again at a fast pace for 3 meters, stays at 3 meters for 2 seconds, and goes towards the motion sensor at a fast pace in 1.5 seconds.
Happy. It's my happy day, I want to sing it all the day. My best friends are always with me. We sing, we dance, we laugh, we
Hello, my name is Conrad and I will be doing graph number 2. Graph number 2 goes steady at 2.5 meters, goes towards at a fast pace to 1.5 meters, stops at 1.5 meters, goes towards at a fast pace again to 0, and instantly goes away at a fast pace to 1.5 meters, stops at the 1.5 meters, and goes away at a fast pace to 3 meters.
happy.
Hello, this is Conrad, and I'll be doing graph number 3. Graph number 3 starts at 3 meters and goes towards at a slow pace to 1.5 meters, stops at 1.5 meters, and goes towards at a faster pace to 0 meters, and then stops at the 0 meters.
Hello everyone, this is Kason Kelly and I did graph 4 in this lab. The graph you see is a visual record of my movement over several seconds, captured by a motion sensor. It's called a position time graph and it tells a story about my motion. The horizontal axis represents time measured in seconds and the vertical axis represents my position in meters relative to the motion sensor. The key to understanding this graph is to look at the slope of the line. A positive slope, like the first section, means I was moving away from the sensor. A negative slope, like the one that follows, means I was walking back toward it. The steeper the slope, the faster my speed. With that in mind, let's break down exactly what I did. From 0 to 3 seconds, I started right at the sensor's location, which is our 0 meter mark. I then walked away in a straight line at a constant speed. You can see my position steadily increasing until I reach my farthest point, 2.5 meters away from the sensor. Then, from 3 to 5.5 seconds, I changed my direction and began walking directly back toward the sensor along the same straight path. I walked at a constant speed until I arrived right back where I started, at the 0 meter mark. Next, from 5.5 to 7.5 seconds, I immediately started walking away from the sensor again. I repeated my first action, moving at a constant speed until I once again reached 2.5 meters from the sensor. Finally, for the last half second, from 7.5 to 8 seconds, I started to walk back toward the sensor one last time, but I stopped the experiment at a position at roughly 1.9 meters. In short, this graph is a perfect representation of walking away from a point, walking back to it, walking away again, and then beginning the journey back one last time. This process of capturing motion with a motion sensor is a simple way but effective way to visualize how position changes over time.
Happy, 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 happy. Yeah, I want to sing it all the day. My best friends are always with me. We sing, we dance, we laugh, we are happy every day. Have fun with us, let's say happy.
Hello, my name is Gregorio Olivas and I did the last graph, graph 5. The y-axis represents the position and the x-axis represents the time. So the graph starts off by constantly standing still for 1.5 seconds, then moves away from the origin for 1 second, then moves towards the origin for 2.5 seconds. After that, it moves away from the origin for 1 second to next stay constantly still for another 1.5 seconds, then moves away from the origin for 1 second, then moves towards the origin for 0.5 seconds.
Happy, 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 happy.
Hello, my name is Damien Martinez and I worked on the activity 2 for lab 1. Our group got these results. Our graph differs slightly from the original graph. It varies in time length. It is longer than the original graph, and it also varies in position. It has a shorter position than the original graph. Some of the reasons why it's different is just because we were not able to move fast enough like it was on the graph. I'm not sure if the graph was simulated or if it was a real something that someone did, but we were not able to move quickly enough to get the graph as spaced out as it was in the original. And also our position wasn't the same because we just did not have enough space in our lab setting. So if we were to change those two variables, having more space and being able to move in a quicker amount of time, or being able to move more in a quicker amount of time, then our graph would look a lot more like the original, and we would have a smaller margin of error, and the graph would be a lot more representative of the original.
Hi, my name is Gregorio Olivas, and for this lab, Conrad did the materials, the procedure, graphs 1 through 3. Damien did the conclusion. Casey did the introduction and graph 4. I did graph 5, procedure, and the credits. The calculation and experiment was done individually between all of the team members depending on their graph assigned. Conrad did graphs 1 through 3, Kason did the 4th graph, and I did the last graph, graph 5. Lastly, the editing was all done by me, Gregorio Olivas. Hi, my name is Gregorio Olivas, and lastly, these are the 5 annotated graphs as shown in the example in the instructions. Each Roman numeral has a different motion it is taking place in the graph, and each graph has a different key. On the bottom graph, number 1 is moving away from the origin, number 2 is staying still, and number 3 is coming towards the origin. On the top left, the second graph represents number 1 as standing still, number 2 as coming towards the origin, and number 3 as moving away from the origin. On the middle right, this is graph number 3. It showcases number 1 as moving towards the origin, number 2 as standing still, and lastly number 3 as moving towards the origin as well. On the top right is graph number 4. It showcases number 1 being moving away from the origin and number 2 moving towards the origin. Lastly, the middle left graph is the graph number 5, and it showcases number 1 being standing still, number 2 moving away from the origin, and number 3 moving towards the origin.